Yes, let's look at this nucleophilic addition reactions of aldehydes and ketones part 2. We have already discussed a few of these electrophilic addition, nucleophilic addition reactions of aldehydes and ketones. That is the first one, addition of hydrogen cyanide and sodium hydrogen sulfide. We have already discussed in the previous video. Let's look at the other reactions, that is Grignard's reagents, addition of alcohols and ammonia and its derivatives in this video. Yes, when we look at this addition of Grignard's reagent to the aldehydes and ketones, yes, here, when we look at this Grignard's reagent, this is a Grignard's reagent. This alkyl group is RMgX is a Grignard's reagent, right? So R is negative, that is partial negative. This is partial positive, that is this one electropositive metal magnesium getting a positive charge here. And this carbonyl group here, we know this is partial positive, partial negative. So the nucleophile, that is R minus, will attack on this electrophilic carbon. So here attack will occur on this carbon atom, resulting in the formation of this adduct here. So R goes to this carbon atom and O will get this. So this is an adduct which on hydrolysis will give you the alcohol. Right. Let's see this reaction. So this is what a nucleophilic addition reaction of Grignard's reagent, which is occurring on the carbonyl compounds. So when we are doing this reaction of this Grignard's reagents with formaldehyde, this is a formaldehyde. So this is negative, this is positive. So yes, this is how the reaction is occurring. So what is the intermediate which is being formed here? So this is R, right? H and H is remained. So RCH2 OMGX. Right? This on hydrolysis will give you primary alcohol. This is a primary alcohol. So from formaldehyde, we are getting primary alcohol. From aldehyde, other than formaldehyde, how the reaction is occurring? Yes. So what do you get again? This is negative. This is positive. This is negative, negative, positive. So nucleophilic attack on this electrophilic carbon. So this, let me write this as R dash. So this is OMGX. This is R dash H, which on hydrolysis will give you what? Secondary alcohol. This is secondary alcohol. Right? So with ketones, if I carry out the reaction with Grignard's reagent, again, positive, negative, negative, positive. So nucleophilic attack on this carbon atom. So what is the intermediate I'm getting here? So let me write this as R dash. So this is R dash, R, and R is remained OMGX, which in hydrolysis will give you tertiary alcohol. So with formaldehyde, after the nucleophilic addition reaction of Grignard's reagent with formaldehyde will give you primary alcohols. With aldehydes other than formaldehydes will give you secondary alcohol. With ketones, we are getting tertiary alcohol. Okay, right. Then to this aldehydes and ketones, when we are carrying out the nucleophilic addition reactions of this alcohols will give you acetals with aldehydes and ketals with ketones. Let us see the reaction now. When this aldehydes, when react with monohydric alcohol, so what is monohydric alcohol? The alcohol which is having only one OH group is monohydric alcohol. One equivalent of monohydric alcohol in the presence of dry HCl gas will give you this hemiacetal. This is called as an hemiacetal. It's called as alkoxy alcohol intermediate. So this is alkoxy alcohol intermediate because here alkoxy group and alcohol group. Right? So again, nucleophilic addition reaction will take place and then second molecule of this ROH will attack, resulting in the formation of this acetal here. Right. With ketones, the reaction occurs with the dihydric alcohol. For example, ethylene glycol here, which is a dihydric. We can see two OH groups here in the presence of dry HCl gas, again dilute HCl. We are going to get a cyclic compound, which is called as ethylene glycol ketal. And plus water molecule is eliminated. So this is a nucleophilic addition elimination reaction. So addition reaction and then elimination reaction. Right. So now let's look at the addition of ammonia and its derivatives to aldehydes and ketones. This is carbonyl compound, but this is what the ammonia or its derivatives. If Z is H, then it is ammonia. Z is something else like alkyl, aryl, OH, NH2, C6H5NH, NHCONH2, semicarbazide, then it's called as what? Derivative of ammonia. Right. So again, this is positive, this is negative. So nucleophilic addition reaction of this will occur on this electrophilic carbon, resulting in the formation of this intermediate. This is a reversible reaction, which is acid catalyzed. It was catalyzed by what? Acid here. And it is a reversible reaction, right? So NHZ and H will go here. Right? So this nucleophilic addition reaction will occur, resulting in the formation of this intermediate. This is intermediate which is being formed, which readily loses water molecule. Right? This readily loses water molecule, thereby shifting the equilibrium towards right side. Yes, but we can see the equilibrium here, but it shifts towards the right side because the intermediate which is being formed readily loses a water molecule, resulting in the formation of this product formation. Yes. So let's look at a few of this, how these are added and how the elimination of the water molecule addition elimination reaction. Right. If suppose the Z, this is the reaction, how it is shown here. So Z is H, that means ammonia. What is this? This is ammonia. This is a reagent name. So what is this? NH3. So what is the intermediate, carbonyl, not the intermediate, carbonyl derivative. What is a carbonyl derivative which is being formed here? So I want to write this. C double bond NH. Z is H. So I'm writing H here. What is the name of the product? The product name is called as imine. If Z is H, the product name is imine which is being formed here. Right. If Z is R, that is what? R NH2, right? This is what? NH2R. That is what? This is called as amine. You know that this is amine. What is a carbonyl derivative? Double bond. Z is substituted by R. This is called as substituted imine or shift space. This is nothing but the shift space. Right. If Z is OH, so Z is OH, NH2OH. So what is this? Hydroxylamine. Hydroxylamine. So what is the derivative which is formed here? This one, double bond, N, Z is substituted by OH. So what am I calling it? Oxime. Simple. Hydroxylamine, oxime. This is ammonia, amine, substituted imine or shift space, hydroxylamine, oxime I'm getting. If Z is NH2, so what is the reagent here? This one, NH2, NH2. So this is hydrazine. You must be knowing this. So what is the product which is being formed? C double bond N NH2. What is the name of this? Hydrazine, hydrazone. right? Hydroxylamine, oxime, hydrazine, hydrazone. Yes. Next one here, if the Z is NH, this thing. So what is the reagent name? So whole reagent, I'll write it NH2, NH. So what is this? Phenyl hydrazine. So instead of NH2, NH2, one H is replaced by phenyl group. So this is what? Phenyl hydrazine. Right? So what is the derivative which is formed here? C double bond N. Instead of Z, I am writing what? NH, this group. This group. So what is a product name which is called as phenyl hydrazine, phenyl hydrazone? Okay. Yes. Now, next one is at 2 and 4 positions, same thing. I'm writing Na2 groups. 1, 2, 3, 4. So if I write the whole reagent here, so it will be NH2, NH at 2 and 4 positions, NO2 group. Right? 1, 2, 3, 4. So it is nothing but what? Phenyl hydrazine. In this phenyl group at 2 and 4 positions have nitro. So what is it? 2,4-dinitro. 2,4-dinitro phenyl hydrazine. Okay, simple. So first one is hydrazine, NH2, NH2. One H is replaced by this group. So it is phenyl hydrazine. So H is replaced by what? Phenyl group. To the phenyl group, I'm adding nitro groups at 2 and 4 positions. 2,4-dinitrophenyl hydrazine. So what is the product I'll get here? NH at 2, 4 positions, add this nitro. Simple. So what is the name of this? 2,4-dinitrophenyl hydrazone, 2,4-DNP. This is 2,4-DNP. Phenyl hydrazone. Done. Last one here. Yes. If Z is NHCO, NH2. What is R? I mean, Z is this thing. So what is the reagent name here? So what? First, I'll write the reagent here. NH2. The Z is what? This one. NHCO, NH2. So how do you write the product? Double bond N. Write this. NH CONH2. So this is called a semicarbazide. So the product will be semicarbazone. Right. So depending upon the reagent name, we can write the name of the product. Simple. So this is the reaction with what? Ammonia and its derivatives. Right. These are some of the nucleophilic addition reactions of aldehydes and ketones. If you like this, please do like, share, and subscribe my channel. And if you want the video to be made on any particular topic, please share it in the comment section. Yes.